Hi guys, this is Sagnik Das, and as you already know, I am currently a first year student at Computer Science and Engineering Department at Jadavpur University. All right, and I would be covering the mechanics section of you. So the first topic that we would be starting today is vectors. All right, you are aware of vectors, what they are. You have heard about it in your 9th and 10th standards, I guess. All right. So without wasting much time, let's start. All right. So vectors. Okay. So what are actually vectors? Right. So vectors are physical quantities that have a magnitude, a direction. This you already know, right? But maybe the fourth point which you are not aware of, I guess, is, but it is really very important. They follow vector law of addition. All right. So what are vectors laws of addition? We would come to that later on. So now let's get a feel of what vectors are actually. All right. So the physical quantities, they can be divided into two subgroups like scalars and vectors, as simple as that. Okay. So what are scalars? Scalars are those quantities which have only one thing, that is magnitude. That is, and magnitude is sufficient to describe a scalar quantity. So what are examples of scalar quantity? For example, let's take mass or distance or say speed, okay, or say work. Like suppose you carry you have a thing 5 kg weight, a block. You carry it 5 kg above your head here, okay, from the ground, 5 meter. So the weight would be the work done would be simply mgh, right? Joules. So there is nothing more to this. Just this is sufficient to describe our work done, isn't it? The same applies for mass. Suppose we have a 5 kg mass and we put another 5 kg mass over it. So simply the entire system now measures 10 kg weight. As simple as that. Okay. So we simply add it. No complications. They simply follow the algebraic laws of addition, subtraction, and everything. Okay. So these are not much difficult to deal with. Now problems arise when we deal with vector quantities. For example, take this thing. Suppose we have a ball. All right. Now what we do is we apply 5 Newton force to it in this direction. So obviously you are getting a sense of what's going to happen to the ball, right? It's going to start moving towards the right. No problems with that. Now what we do is we add another 5 Newton force somewhere. So now we see that how vectors are different. Suppose we take the 5 Newton force along this direction only. So what is this equivalent to? Like they would simply add, suppose you are pulling this ball with 5 Newton force and you have another friend who is simply pulling the same ball with 5 Newton force. So simply the whole thing is moving with 10 Newton force, isn't it? Simple as that. But now, suppose you are pulling it with 5 Newton force this side and your friend starts pulling it with an equal and opposite force from the other side, opposite side, right? So he starts pulling it from this side. So now tell me something. Is the ball going to move anywhere? No, right? Because you are applying equal and opposite force on both directions on the ball. So it's going nowhere. So it's simply the net force on the ball is simply now equal to 0 Newton. So the same 5 Newton force, when you apply it in this direction, it added up like to 10 Newton. And simply when you did to in the opposite direction, okay, it simply subtracted the existing force. So now the net force is 0 Newton. So you are seeing why the direction is important. Now suppose let's take this. Okay, we apply 5 Newton here, and the second force we apply it in at right angles to this. Okay, we apply it at right angles to this. So tell me, what do you think what's gonna happen to the ball? Let's give it a thought. All right, what's gonna happen to the ball? So you just think about this intuitively, right? Someone is pulling the ball from this side, and someone is pulling the ball also above. So in which direction is the ball gonna go? Right? It's gonna go like somewhat like this at 45-degree angle. You're getting the intuition, right? Why I'm telling 45-degree angle? Because there's an equal force. You are pulling it with equal force on above and also from the side. So it's gonna go somewhere like 45 degree from here, right? That we would come to later on. We would know that this simply we can find the magnitude by simply using the parallelogram law. Simply what would be doing is like it's like finding the hypotenuse of this triangle. Like we add another 5 Newton here. We complete this rectangle basically. So the resultant is gonna be this. Basically, it's a square, not rectangle. So the resultant is gonna be simply 5 square plus 5 square. This is 5, this is 5, so that's gonna happen. So simply 5 root, that's gonna happen. So this is between, so what is the maximum thing that could happen to the ball? Maximum force, that is 10 Newton. Minimum is 0 Newton, and 5 root 2 is somewhere in between. So we are getting a sense why the direction is important, right? We are getting a feel about this. All right. So now let's come to our next point. That is how we pictorially represent a vector. Like only getting the sense wouldn't do, right? We need to represent it somehow. Representation of a vector. Okay. Okay, so what we do is to represent a vector. Sorry. This is it. Alright. So we just draw a ray. Okay. This is called the tail of the vector, and this is called the head of the vector. Suppose it's vector P. We represent a vector by a variable with this arrow over this thing, like any alphabet with this thing. That's simply the representation of a vector. And pictorially, this is this line. This is the tail. Let's say OP. Let's name it OP. So this O is the like tail of the vector, and P is like head of the vector. Also, this length of the vector, which we represent as mod of OP. Okay, mod of OP. This represents the magnitude of a vector. All right. Like suppose we have a suppose OP represent a vector whose magnitude is say 5 Newton. 5. Okay, let's not go into force or anything. Okay. So if we want to represent another vector that also goes in the one of half the magnitude but of same similar direction, what we would do is we would simply divide it into half, take this length and draw that length. Like this vector would have magnitude that is 5 by 2. Right, here we're talking about magnitude only. All right. So you are getting a sense was why okay about this thing. All right. So this is why magnitude of vector is important. Now vectors can be of, like, there are many uh, names given to vectors, like some are coplanar vectors or something like that. Yeah. So some are collinear, right? The collinear vectors all start from the same point. Suppose we have three vectors A, B, C. If like they have the same starting point, they are known as collinear vectors. All right. And then there is parallel vectors, like suppose A and B are parallel, okay, of any magnitude. Okay, if they are parallel, I mean pointing in the same direction, okay, they are known as parallel vectors. Okay, so same way, if this parallel vectors, now if these parallel vectors have equal length also, like suppose A and B vectors, now they have like equal length, so simply we would say that these two vectors are equal, so they are equal vectors, as simple as that. Now, one important property of vectors is that suppose we take this vector p, okay, so as long as this vector has the same length and points in this direction, and we don't actually change its direction, so we can move it anywhere in space. Like we can bring it here as long as it has the same direction and same magnitude. Okay, now we can move it here, we can move it here, we can move it anywhere according to our ease. You would say, what's the point in this? What's the point of moving a vector? If we would come to that when we need to find a resultant of of vectors, right? Suppose we have a vector 5 Newton here, we have a vector 3 Newton here. We can simply like join them uh, tail to tail and then find uh, the resultant of this thing. All right. So there's a very important property about vectors. Now we come to something really cool. What is that? Unit vector. Now, what is the unit vector? Basically, it's a vector whose magnitude is equal to unity, right? Now you would say, what's the point in this? Okay, so let me tell you what's the point in this. Suppose we have a vector A, all right. So if it is a vector A, the unit vector which is represented A cap, okay, it's simply vector A divided by the magnitude of A. Okay, so what is vector? Actually, what is a vector? Vector has a magnitude as well as direction. So any vector quantity is simply a product of magnitude and direction, right? So we know that this magnitude is represented by this mod of A thing, all right? So just to give an idea about the direction of the vector, I mean to which direction it's pointing, we use this unit vector. So like simply if we take this direction, this to be vector A, okay, so this direction has a unit vector A cap. So now whenever we represent any other vector in this direction, we can simply represent it like x into A cap, where like x is the magnitude, x is a scalar basically, and A cap. So basically any vector in this direction can be represented as a scalar into A cap. So this unit vector helps us to get a sense about the direction in which the vector is pointing. All right. So now, so we are sensing why this unit vector is important. Now, as you are seeing that, suppose we are dealing with vectors, right? Now in a three-dimensional plane, we live in a three-dimensional world, like, right? So there are like infinite number of vectors. So to represent them in some way or the other, we need a convention, right? Just talking about them randomly wouldn't do. We need a pictorial representation of this thing to get a feel about this thing, and also to solve mathematical problems. All right. So for that purpose, what we do is we form a Cartesian system. All right. So let this be the x-axis, this be the y-axis, and this be the z-axis. Okay. So according to convention, we take the unit vector along x-axis to be I cap, y-axis to be j cap, and your z-axis to be k cap. So you would say, like, what's the point in this? Okay, so let me show it to you simply. First, let's do it in 2 dimensions. All right. So basically, okay. So let this be the x. Let's deal with two axes first. Let this be the y-axis. Let this be the x-axis. All right. Suppose this origin. This is the origin. Okay. And suppose there's a point P here. Okay. Which has a coordinate. Let's say 3 comma 4. So basically this length is your 3 units and this length is 4 units. So according to our convention, how would we represent this vector OP? This straight line basically, it's making it twisted. Okay. So according to our convention, what we do is OP is simply what we said, that the what is the vector? It's basically a product of magnitude as well as direction, the unit vector, right? So what is the magnitude along x-axis? It's 3. And what's the unit vector along x-axis? That's I cap. So it's 3 I cap plus, now along y-axis, right? So along y-axis, what's the magnitude? It's 4. And what's the unit vector? J cap. Okay. And since we are not dealing with the third axis here in this question, so that's simply basically 0 into k cap. So basically it's 3 I cap plus 4 j cap. That's how we represent this vector OP. Now since we have drawn this vector from the origin, okay, we have a special name for this vector OP. Okay, what is that? That's not actually important. Basically this vector OP represents the position vector of point P. That's not very important actually. Okay, so this OP represents the position vector of point P. Also now, what is the magnitude of this vector OP? You're simply getting the sense, like it's 3 and 4, so use Pythagoras theorem, and it's 3 square plus 4 square. So it's simply 5. So the magnitude of OP is 5. Alright. Its magnitude of OP is simply 5 units. Oh, alright. So now going to the 3 dimensions, as we were discussing earlier. Alright. So let's draw this thing once again. Okay, so this is your z-axis, this is your x-axis, this is your y-axis. Now there is something that you need to know about axis. Okay, You just can't name axis in it, axis just randomly. Okay, so this is my z, this is my x, and this is my y. So during naming axis, we follow this right hand rule. Okay, it's everything is a right-handed system here. Like, right. So basically, what's a right-handed system? Right-handed system is simply, suppose we, this is our palm, right hand palm. Okay, okay, so this is our palm. I am very poor at drawing, but you need to get a sense of this. Okay, so what you need to ensure is that when I, this is pointing towards the x-axis, right, along this x direction. So when I do this and curl it towards y, okay, we curl it towards y, it should all the point, the thumb should always point towards the z-axis. It was always point towards the z-axis. So as per my diagram, you can see that this is pointing upwards. All right, but you cannot rapidly just like interchange these two. Like you can't interchange x and y axis like just like that. You can name this one y and this one as x. Okay, so this is a thing. All right, so now this has become messy. So wait. Yeah, yeah. So now suppose we present a cube like this. It would be easier for you to get a feel. All right. Now suppose this is your O and this is your P, right? Which is basically the diagonal of this cuboid. Basically, what we did there, we are trying to represent it in 3 dimensions. Okay. So basically, let the coordinates of OP be like PX, PY, and PZ. So this is your x-axis, this is your y-axis, and this is your z-axis, right? So what would be now the what? So what? How would we represent OP? OP is simply now PX I cap plus PY J cap plus PZ K cap. Just extending what we learned in that 2 dimension thing. PX, what is PX? PX is like the distance along x-axis, right? Like how much one has to travel along x-axis, and py is how much one has to travel along y-axis, and pz is how much one has to travel along z-axis in order to reach that point P in our 3 dimensional system, right? Okay. So now what is OP? OP is simply, as you know, diagonal of the cuboid, which is simply px square. This is mod of OP, sorry. Yeah. So px square plus py square plus pz square. Simply that. All right. So now let me ask you a question. What is OP cap? Unit vector along OP. So that, what is that? It's simply OP vector divided by magnitude of OP. All right. So simply that is pxi cap plus pyj cap plus pzk cap by root over of px square plus py square plus pz square. All right. Pretty simple. Okay. No problem with this till now. Okay. So now let's come to something called displacement vector. Basically, these are very fancy terms. Once you get the hold of this thing, it doesn't matter to you anymore. All right. So basically, we have this thing. Um, 1 second. I'm not writing X, Y, Z all the time. Okay, you're getting a hold of this. So suppose this is your point A. Okay. So its coordinate be x1, comma y1, comma z1. This is your origin. This is your B, which is basically x2 comma y2 comma z2. And this is OA vector. This is OB vector. Now what is OA? Is a position vector of A. Position vector of A, which is simply x1 I cap plus y1 j cap plus z1 k cap. Okay. And what is OB? It's position vector of B, which is simply x2 I cap plus y2 j cap plus z2 k cap. So now, what is AB vector? Okay, AB vector is simply this one. Okay, now suppose a particle was at A. Okay, and it wants to move to point B. So what would be the displacement of that particle? That would be simply equal to AB vector, AB vector, right? So what is AB vector? A vector is simply OB vector minus OA vector, right? So that's simply x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, which is simply, since this is the displacement, so we call it displacement vector. As simple as that. No issues with that. Okay, so if we talk about definition of a displacement vector, the definition says that a displacement vector is that vector which tells us how much and in which direction an object has changed its position in a given interval of time, right? So it's simply like if you find a mod of AB, so basically you get you get how much distance it has covered, distance basically. And also since it's a vector, you get a sense of direction in this diagram. Simple as that. Okay, so no problem with that. Now let's come to a simple question. Okay, so tell me something. A particle is initially at say some 3 comma 6 comma 5. Okay, and later on it moves to 2 comma 4 comma 3. Okay, so what is the initial and final position vectors of the particle? And also, like, what is the displacement vector? Just think about it for 5 seconds. All right, so it's no big deal. Like, so let's represent the initial position vectors r1. Okay, so it's basically 3 I cap r initial, right? This is r initial, so it's basically 3 I cap plus 6 j cap plus 5 k cap. R final, it's simply 2 I cap plus 4 j cap plus 3 k cap. Yeah, so the displacement vector, which is d, that is simply RF vector minus RI vector. Alright, simple enough. So which is your 2I cap plus 4j cap plus 3k cap minus your 3I cap plus 6j cap plus 5k cap. So which is simply 2 minus 3I cap plus 4 minus 6j cap plus 3 minus 5k cap, which is simply your minus I cap minus 2j cap and minus 2k cap. Okay, so it's pretty simple. The displacement vector, right? And the magnitude of the displacement is nothing but root over of 1 square, basically minus 1 square plus minus 2 square plus minus 2 square. So basically that is root over of 9, that is 3 units to be precise. Okay, so that's the displacement. So let's take another sum, I guess the last one for this lecture. Okay, so mm, let's say कि a particle has the following displacements in succession. Okay, so basically what it does is that it follows the sequence of displacements. What is that? First it travels 5 meter towards north. Alright, then it goes 6 meter towards east. Okay, and then it goes 2 meter vertically upwards. So what does that really mean? So at first let's draw our three-dimensional system. Okay, so yeah, so here's your z-axis, here's the x-axis, and here's the y-axis. Okay, so let's switch to pen. So this is the x-axis, this is y-axis, this is z-axis. So what it says is that let's extend this thing. Okay, like this. Okay, so let's follow a convention. Okay, this is, let this be north, this, let this point towards the north, then this is south, right? This is east and this is west, and this direction is upward and this is downward. Simple enough. Okay, so what it says is that it covers 5 meters towards the north, that is it goes 5 meter like this. So what we can say is that if this is a positive x-axis, okay, then this is negative x-axis, right? So if the first displacement, let us represent by d1. Okay, so d1 is nothing but minus 5 of I cap, because the positive x-axis is along this direction, right? So this, he moves along the negative x-axis, and we know that unit vector along x-axis is simply I cap. So along negative x-axis it would be simply minus I cap. So displacement vector di is minus 5 I cap. Okay, so and now let's, what is d1, sorry, then what is d2? D2 is said that it moves 6 meter towards east. Now east is along this direction, okay, along y-axis. Okay, so what is d2? Easy enough, it's 6, and 6 is the magnitude, and what is the direction? Along positive y-axis, so it's positive axis, so it's simply 6j cap. Okay, and the last one, okay, d3, 2 meter vertically upwards, so the upward direction is simply the positive z-axis, so it's nothing but 2 k cap. Okay, that's what it says. So the what question is, find the magnitude of the displacement, right? So what will the magnitude? The magnitude would be nothing but, what is a d net, displacement net? That is simply di d1 plus d2 plus d3, right? So that is nothing but minus 5 I cap plus 6j cap. plus 2k cap. And what is the magnitude of the displacement? It's nothing but root over minus 5 square plus 6 square plus 2 square. So this is basically what root over of 25 plus 36 plus 4. So basically it's root over of 65. In case I haven't done any calculation mistake, okay, I guess it's fine. Yeah. So this is my final answer. Okay, 60 root 65 units. So in this lecture we get a brief idea about vectors. Okay. In the next lecture we would be studying about the vector laws of addition and the angle between the vectors and all those stuff. So please like and share our video and keep supporting us. Thank you.